In this problem we're being asked to find the solution set to the equation square root of x plus 3 equal to 3 minus x. So solution set just means all of the possible values of x that will make that equation true. So how do we solve? Well, the first problem we have is we want to get x by itself, right? We want to find all the possible values that x could take on that would make this equation true. But unfortunately it's bundled up underneath this radical sign. So how do we get rid of a radical sign? Well, we could square both sides. So let's do that. We take square root of x plus 3 and we are going to square that on the left. And if we square the left, we also have to square the right. And this is where you can run into trouble. If you square both sides of an equation, then what can happen, and what will happen in this case, is this 3 minus x quantity, when it gets squared, x goes from being from the first power to the second power. And what's the difference between a polynomial that is only of the first order, that only has x to the first power, versus a polynomial that has x to the second power? Well, they have a larger order polynomial has more solutions. So what's actually going to happen here is we're going to solve this and get two solutions, but both of them won't necessarily work, and we'll have to go back and plug into the original and see if they both work, and it's likely that one of them won't. But let's keep moving forward and we'll see how it turns out at the end. So if we take square root of x plus 3 and square it, then anything that you're taking the square root of that's then being squared just becomes itself, right? So this just becomes x plus 3. On the right side we have to FOIL. We have 3 minus x squared, which is the same as 3 minus x times 3 minus x, and we now have to FOIL that. So let's see what that turns out to be. 9 minus 3x minus 3x plus x squared. So let's do some simplifying on the right there. I'll keep the left just as it is. The right side will become 9 minus 6x plus x squared. And now I'm going to bring everything over to the right. So I'm going to subtract x and subtract 3. So this side will become 0, and the right side will become 6 minus 7x plus x squared. And now lastly, I'm just going to change the order of what we have on the right side so that it looks like a standard form second order polynomial that you're used to seeing. And that should be very solvable. So we can factor and find out what x actually equals. And what would that right side factor to be? X minus 6 times x minus 1, right? Has to multiply to positive 6, which these do, and has to add to negative 7, which they do. So that means that the possible solutions would be x equals 6 and x equals 1, right? We set each of these terms equal to 0 and solve for what x would be. X equals 6, x equals 1. So the answer must be number 3, right? But wait, we have to make sure both of these answers work in the original equation. So let's see what happens if we plug them in. So taking x equals 6, so square root of 6 plus 3. So alright, so we're testing 6. So here's our test for 6. X plus 3 is 6 plus 3 is 9. So we have square root of 9. That's a little messy. Make sure you can see that. Equals 3 minus 6. Is that true? Well, square root of 9 is 3, and 3 minus 6 is negative 3. So that does not work. So we have to throw 6 out. Now let's test 1. So x plus 3 again, so 1 plus 3 is 4, so we have square root of 4 equals 3 minus 1. So 2 equals 2, and that works. So 1 we're keeping in. So the solution set only contains one answer, x equals 1, and the best choice is the first one.